So in this video, we're going to talk about how to solve a system of linear equations through graphing. And so what you're going to have is two linear equations. And basically, I'm going to have to graph the top one. I'm going to have to graph the bottom one. And what you're looking for is the intersection point. Okay, so the point that lies on both lines. Remember, every coordinate point is an XY value. So if I have a coordinate point that's on both lines, that's an X and a Y that are going to work in both equations. Now these ones are going to be easy to graph because they're in slope-intercept form. So remember, this is my starting point. That's going to be my y-intercept. So for this equation, I'm going to start at -1. My y-intercept is -1, and my slope is 2, which I can put over 1. So I'm going to start on the y-axis at -1, and then I'm going to go up 2 over 1. So I'm going to graph that. So I'm going to flip it over. This is my y, this is my x. I start at -1, and I'm going to go up 2 over 1. 1, 2, 1, 1, 2, 1, 1, 2, 1. Now, it's always a good idea with these to work backwards as well, because that intersection point might be back here. So if I normally go up 2 over 1, I'm going to go down 2 to the left 1. I'm going to work backwards. And I'm actually going to leave the points like this instead of connecting, because most likely, especially at the 8th grade level, it's going to be one of these points that are going to intersect. Okay, so now I'm going to do my other line. You can see that my y-intercept is 5. And remember that you can slide a 1 in here. So my slope is -1, which I can put over 1, and that means down 1 over 1. So I'm going to start at 5. 1, 2, 3, 4, 5. And then I'm going to work down 1 over 1. Down 1 over 1. Down 1 over 1. And right there is the point that's going to intersect. And I can draw these lines to show you that. But that is my intersection point. So if I count, that is the coordinate point. 1, 2, 1, 2, 3. So they intersect at the coordinate point 2, 3. That means these lines are the same when x equals 2 and y equals 3. So when x is 2 and y is 3, these are the same, and I can plug that in. I can do 3, 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3, so it works in that equation, but it does have to work in both equations. So 3, -1 times 2 plus 5. -1 times 2 is -2 plus 5 is 3. So when I check it, it does work in both equations. And so that's all you have to do. You have to graph your two lines and find the intersection point. Now, a couple things that you may see. Some quick reminders about graphing, okay? First of all, you might have to work backwards like I did. So remember how to work that slope backwards in case the intersection point would have been back here. Also, remember that if you don't see a coefficient, there always is one. So technically my slope there is 1. Also, if you see just this, remember that that means technically you're adding 0, and so your y-intercept is 0. So you want to make sure that you start there.